Okay, how's everybody doing? Good. How did it go with assignment 6? Goodish. So I don't know. Put up your hands if you think you got a decent mark on assignment 6. Okay. Good. I don't know. Something like 70%, let's say. Yeah. So 70% of the non-bonus questions, let's say. Good, because well, the next 2 assignments are available online, and they're also using Pygame. So you kind of, assignment 6 was sort of a warm-up exercises, and the next 2 are actually, one is making a sort of a crappy game. Just to get you going, and then the one after that is making your game. and as we've seen, there are some pretty good games that have been made using Pygame in this class in previous years. So I have big hopes for you guys. To get you motivated, we will devote one of the tutorial weeks. People will show off their game. So anybody who's interested, towards the end of the semester in one of the tutorials, basically, there'll be a chance for people to show off their games, let other people play them. So a little games fair, if you like. And of course, there'll be a small collection of the best games distributed to the class. Okay. So today I just want to do a little bit of midterm review. I don't have that much to do. How many of you have looked at the sample exam, the one from 2 years ago? Okay. That was in the tutorial today. Some of you, So, the tutorial is basically, the instructions for the tutorial are basically the best instructions for studying for the exam. Unfortunately, for those of you with a Thursday tutorial, that's not super helpful. It means that you're studying a few hours before. So I'd suggest maybe you try and do the most of that tutorial work before your tutorial if you're on Thursday, and then use the tutorial to actually discuss and learn things. Otherwise, what we can do is just go over maybe a few review type questions, see how you guys are doing, and maybe look at a couple of things that we didn't look at so closely yet. They won't always be on the midterm, but they're good to know. One of the things I'd like to look at, which really won't be discussed on the midterm, but you've reached the stage now where you should start to know this, is the Python style guide. So, as you may or may not know, Python is a language, unlike many languages, it was not invented by a committee. It was invented by a single guy named Guido, who has very strong feelings about, the way programming languages should work. And he has reasonably good taste about a lot of things and made some good decisions. So that's why, Python is a fairly clean language, cleaner than languages with a big history, things like Java, which, comes from C++, which comes from C, which comes from PL1, and so there's a lot of cruft that builds up. Python sort of started from scratch. It was just what Guido wanted, and so he writes these PEPs. So these are guidelines for Python programmers, and one of the important ones is PEP 8, which is about style guidelines. So this tells you nothing about, how programs, well, it's nothing about how to write Python necessarily, but more just about how you should lay out your code, what your code should look like. And I'd like to just go over that quickly so that you guys are doing something that's in line with what other Python programmers around the world are doing. So the first thing in this PEP is sort of a disclaimer that says, okay, here's this very complete guide about all the way you should write Python code. And the first thing in there is some rules about when you should ignore this guide. So if you're starting a new project from scratch, like we've been doing in this class, every assignment that you've done has been pretty much from scratch. The games that you write are from scratch. Then you should probably follow the style guidelines in this guide because it's what other Python programmers all around the world are used to. But if you get involved in a big project that already exists and they're using other guidelines, well, stick to the existing guidelines. Don't come in and start doing things differently than the rest of the project, otherwise you get a big mess. So sometimes you want to ignore this thing, but that's usually when you get involved in a bigger project that's already got some guidelines associated with it. Okay, so indentation, we've just done this implicitly from the beginning. Use 4 spaces per level of indentation. Not tabs, not anything else, 4 spaces and for each level. And if you need to break a line because it's getting too long, then you also use indentation to help distinguish that. So, in this example here, you have a long function with a lot of arguments, while you use indentation to show where the arguments continue on the next line. Don't do things like this. Don't continue a line and indent with 4 spaces this way. It looks like this is somehow another indented piece of code. And, and similar, don't use 4 spaces for continuations like this. Just do something nicer. Follow the examples above. Some rules about if statements. I don't always follow these. Perhaps I should. And that is, usually when I break an if statement across multiple lines, I use a backslash to do the continuation. Perhaps cleaner way to do it is just to use parentheses, because when Python sees an open parenthesis like this on a line, and no matching closing parenthesis, it knows to just keep reading to the next line. I usually put a backslash there, and that's not the right way to do it. Some rules for doing lists, and should you use tabs or spaces? Well, it tells you explicitly. You should use spaces. They're the preferred method, and it's 4 of them. Here's one that many of you don't know, and many programmers all over the world don't do this, and I think they should more often. Maximum line length. A line should never be more than 79 characters long, including all the spaces and everything else in the line. There's a few good reasons for this. Very often people work on code on terminals with very limited capabilities. So if you do web development, you will often find yourself actually working on a machine which is somewhere else that you've SSH'd into, and you're actually just working on a little terminal window. And anytime you get lines which are more than 79 characters long, well, you can't see the whole line. So either you get a bad line wrap or something else. A bigger issue, or another issue, is simply accessibility for people with visual impairments. So I've known 2 programmers who couldn't see at all. They had no eyesight at all. And these two guys both use Braille terminals. And that's usually just a line of text that they can see one line at a time that appears above their keyboard. And of course, that thing is limited in width. It's actually 80 characters wide. Long lines cause problems for them. They can't see the whole thing at once in some sense. So keep it at 79 characters. If you find yourself expanding your window so that your lines are fitting, you're doing something wrong. So don't do that. In fact, it's even best if you can set your text editor to give you a guide at 80 characters to know when you've gone too far. And then there's guidelines on how you should break up long lines if you have to. Blank lines. So Guido even cares about the use of blank lines. Top-level functions, so the normal functions that we define, usually leave 2 blank lines between them. Sometimes, if you have a group of functions which are very closely related, you might just leave 1 blank line inside them. Inside a class, you usually leave 1 blank line in between functions that you define in that class. They call them methods here. And then between classes, again, two blank lines. Source file encoding, well, usually UTF-8 or ASCII-2. They even care about how you do imports. Although it's possible, this is allowed, you can import 2 modules on 1 line like this. It's recommended that you actually use 1 module per line. If, however, you want to, from a module, import a few functions, like from math, import, you might import square root and log, then that's okay to list out the individual functions on the single import command. And they care about which order you do things in. So first comes the stuff that's in the standard Python distributions, then import any third-party stuff, and then import any stuff that you've defined locally in your application. So there's some examples there. Spacing, even within expressions, all of these things, even though they're valid, there's ways that look good and ways that look bad. If you were defining, for example, well, more or less the rule is don't use extra spacing unless it's helpful, unless it somehow shows something or breaks it up nicely. In particular, don't put extra space before and after parentheses. All that does is make the line longer without really helping people read it. Do use space sometimes in arithmetic expressions or comparison things, and sometimes use space to help with order of operations. I think there's an example of that there. So, don't leave spaces, between indexes. Some of these things just seem completely horrible to me to look at, like seeing that space there, even though it's completely legal. Don't do things like this. Try and do fancy alignment tricks like this. Not good. And there's even recommendations. Any comparison operator, maybe you put space around it. But arithmetic operators, you may or may not use space except maybe to help with order of operations. So here's an example where x squared plus y squared it's a little bit easier to parse if you write it this way. You see the order of operations appearing that way. Generally, don't do compound statements. Don't have more than 1 statement on a line, including an if statement or a while statement. This is one that I want to break sometimes. You shouldn't have an if statement where the body of the if statement is on the same line. because, well, because Guido says not to do it, even though I actually think it looks better sometimes. But listen to Guido. Comments, different kinds of comments. So block comments, usually these are the ones you put at the beginning of a function body or before some bit of code. They're indented at the same level of code that they're describing. And inline comments are basically comments right on the same line that describe a line of code. I'm not too fussy about these, but I do agree strongly with what he says here. Don't write comments that tell you exactly the same thing that the code does. If the code says x equals x plus 1, you don't need a comment that says increment x. That's obvious from the code. On the other hand, it could be helpful to have a comment to say why you're incrementing x. So if you're drawing something and you want to pad out the border, you might say, I'm adding 1 to x here because this makes up for some border around this thing that I'm drawing. Document strings are actually really important ones. These are the triple quote comments. You put them before functions or right after the name of a function. We've been using them since day one to describe what a function does. You also put them at the top of a file to describe what the file does or what the module does. Maybe at the tops of classes to give a description of classes as well. And there's a reason to do these in a very specific way. So the first thing you do, the first line is a short description of what this thing is. And if you want to, if you need to describe more about it, you do that on subsequent lines after a space. And the reason for doing it this way is there's actually tools that will take your Python code, process these comments, and generate a whole beautiful web page that describes everything in your code. These are automated documentation tools. They're good for that. Version bookkeeping you'll learn about when you learn about how to use version control. And the other sort of, there's lots in here, and I recommend you read it. But one of the things that I think is probably the most important thing in here, because as you learn to program in other languages, you'll come across all of these things, is the different kinds of naming styles that you can have. Starting with the simplest things, single lowercase letters for the names of variables and functions. So it's fun to write code where everything is named with a single lowercase letter. Sometimes not so much fun to read such code. Single uppercase letter is another style of naming. Sometimes it's useful. Things where names are all lowercase, things where names are lowercase with underscores used to separate words, all uppercase with underscores. And then there's this capitalized words, sometimes called camel case, because these things look like camels. They have bumps at the beginning of each word because the beginning of each word is capitalized. Mixed case, where every variable name starts with a lowercase letter, but then any subsequent words are capitalized. And then really bad is capitalized words with underscores. Super ugly. So these are things that different languages use one or more, or sometimes even all of these things. So it's good to recognize them. And they tend to mean different things. So for example, in Python, we use all uppercase typically to mean a variable which is not really a variable. It's just a value that never changes. So let's say you're defining some game, or well, we did this actually in our game. We have frames per second that we always fix at 30 frames per second. So we called that thing, we created a variable called FPS, all uppercase, set it to 30 because it's something that will never change. So uppercase is typically reserved for things that never change. Sometimes uppercase with underscores for the same reason. lowercase with underscores is the standard for most things in Python. For variable names and function names, you use lowercase with underscores to separate the words. Mixed case and capitalized words, usually you use these for the names of classes in Python. So that's, I mean, you see that I've been doing this, but never really explained why. Well, the reason why is because it's what Guido suggests. And one other thing about names is this single leading underscore and this double leading underscore, or double leading and double trailing underscore. So two underscores leading a name and after a name. Where have we seen that before? Yep. Yeah. So really special methods inside of the Python that have methods, object methods that have special meaning in Python. These things are reserved. They get this double underscore, the name of the method, and double underscore. That means these things are used specially and internally, and they have really special meanings. Like if you redefine double underscore EQ double underscore, then this is actually the method that gets called by Python when you compare two things using the equals equals method. And you know, there's also things like double underscore plus double underscore, which is what happens when you try and use the plus operator in Python. There's a whole list of these things you can overload. We've looked at those. Double leading underscore, we shouldn't worry too much about yet, but single leading underscore is one that's useful, and it's important that you know what this is if you come across it. So if inside some class or module I see something like a variable that's name starts with an underscore, that's supposed to mean that this is a variable that's used internally by this class, and don't rely on this variable being there or having the meaning that you think it means in the future. In other languages like C++ and Python, these things are usually called private or protected variables. So it has absolutely, I mean, it does nothing in Python. It makes no real difference. You can still go ahead and access this thing and do whatever you want with it. But every time you look at your code, you'll see this ugly leading underscore here, and that's supposed to remind you that you're accessing something that maybe you shouldn't be accessing. You better have a good reason for doing it. In languages like Java and C++, you would declare this thing to be a private variable or a protected variable so that people don't access it who shouldn't. But in Python, it's more of a language for polite people. You don't explicitly stop someone from accessing something they're not supposed to. You just remind them that it's not a good idea. They can do what they want after that. Okay. And here's a list of stupid names in every programming language. L, never use that as a variable name, lowercase l. It's impossible, it's hard to distinguish between L and 1 very often, or even uppercase I. And of course, capital O is a bad one because it looks like a 0. So don't use those. Yeah. So I don't know, there's lots in here. Yeah, and I encourage you to read it if you ever get involved in any big Python projects, or you're starting any Python projects. It's a good read, and I tend to agree with most of the stuff in here, but not all of it. But if I was writing, if I was starting a new big Python project, I'd probably follow all of this just because everyone else does. Okay. So that's linked to on the course web page, I think, if anyone is interested in it. Couple of other things, or one other thing. Well, actually, maybe now we should just work through a few examples of things that you might see on the exam. And these are basically things that you've either seen on assignments before and hopefully done well on or not done well on, but you should be able to do them. So from the first assignment, one of the questions you were asked was to write a function that converts a weight given in pounds to a weight in kilograms. Can all of you do that now easily without any problems? How would you do that? So you want to define a function, pounds to kilograms. What does that code look like?
Find the right number.
Yeah, so what's the relationship between pounds and kilograms, roughly? So a pound is, or a kilogram is 2.2 pounds. So if I'm going from pounds to kilograms, yep. Yeah. So you return W divided by 2.2. There's actually a more precise conversion factor, but we'll live with that one for now. If you want to check if that's right, well, you know a kilogram is 2.2 pounds. So if I input 2.2 pounds in here, I divide by 2.2, I get 1 kilogram. That looks right. Anything we should remember to do here? Yep. It won't cause an issue for this one, but it could cause an issue for other places where we use division. If you're using, well, if there's any chance you might use Python, a Python version less than 3, you usually want to import division.
String.
What's that?
As a string, like your number.
Well, it depends what you're asked for. I mean, we can write a comment for this that says what it is. Return the weight W in pounds as an equivalent weight in kilos. There it is using the docstring syntax. So this tells you what it's doing. It's really just returning the weight. It's not going to print it. It's not going to format it. It's just going to convert it from one unit to another. So you put in a number and you get a number. So if I give you a length in feet, so it's a number, and I want to convert it to feet and inches. So what does the output of that look like? Yep. Because Guido says to. That's usually the reason. We always do what Guido says. So if you look at these documentation strings, this is the format for documentation strings, triple quotes, and a short description of what the function does. And if you need to make, if you need to write a paragraph about it, you leave a blank line and write your paragraph about it. This is just the standard for documenting functions, classes, all of these things, and modules as well. So, so if you really want to be fancy, it's like he says finish it with like that. So this is really, Guido would be happy with this kind of thing in every file you write. All right, so feet to feet inches. What are we returning? Yeah?
So we take the length divided by with the double factor and by 12, right?
Yeah, so okay, so we want to return the feet part. So somebody might give us a number like 6.5, and we would like to return 6, the integer 6, and feet, and 0.5, that translates to 6 inches. So how do we get the integer part of it? We can make it into an int. There's a couple of ways. And how do we get the other part of it? Yeah. Mod what?
Mod f by 1.
Aha.
By 6.
We actually want f mod 1, right? We want the remainder when we take f and divide it by 1. We get then the fractional part of it. And then we multiply that by 12. And this, remember, when you take things and separate them by a comma like this, that's creating a tuple. If you want it to look a little bit nicer or make it more explicit, you can wrap the parentheses around it, but that's optional. So there's the code for that. There's other ways to do it. We could also do integer division of f by 1 instead of converting to an int. That works also. So you want to make a string that has n star characters in it. There's lots of ways to do this. Give me one. Yeah. Well, we don't want to print it. We just want to return it. Yeah. So like that. Yeah, that works. I mean, we can check. Oops. That does it. Any other more long-winded ways of doing it? If you like, you can use a for loop. So what would the for loop look like? For I in range n.
Wait, why don't you add it to an array instead of a string?
Okay.
You said that it would stop you to do that.
Sure. So we create an array, and then what do we add to the array? Sure. So we say something like a.append star. Yeah. So now we have an array with a bunch of star characters in it, n of them. What do we do with it now? Yeah. Well, what happens if I return the array? Does that give me a string or an array? You turn the array into a string. How do you turn an array into a string? That won't do it. That'll give me a string with all kinds of square braces and commas and things in it. Yep. Join. So there's this string join method that says if I have an array of strings, I can concatenate them all together, each one separated by whatever I want. In this case, I don't want them separated by anything. I just want them separated by no space at all, so by the empty string. So that's what I end up doing here. We can check that out. So there's an array with all those stars, and if I join that array, I get this single string that contains all of those stars. You could do it recursively.
But you can't do it over 997.
But then you can't do it for more than 997 things. So maybe we won't do the recursive solution. Or I don't know. Let's do the recursive solution. So what's the recursive solution look like? It's a good lead-in for something we'll be studying shortly after the break. Star plus stars of n minus 1. Yeah, join would be faster, but let's not worry about that for now. Does that work?
What happens if it's negative?
I'm not even worried about that. What happens if I run this code now? It will go on forever. So what if I'm doing a recursive algorithm like this, what do I need to do? So I need to tell it when to stop, and I'll stop if n equals 0, then you can just return the empty string. That's no stars at all. There's another way to do it. Going back to this solution, just to show you something you may sometimes see in code, underscore is a valid variable name, just a single underscore. Why would you ever use such a stupid variable name? Well, here you'd use it because if you notice, we never, we had I here, but we never actually used the value of I. All we care about is that this next piece of code executes n times. So anytime you find yourself writing a for loop where you never actually use the thing that's iterating over, the typical thing to do is to use an underscore there. You'll find these in list comprehensions as well. Sometimes all you care about is the number of times it executes, not the values that it actually takes on while doing that. Yeah, and then of course the obvious way of doing stars, or if you've never written Python code before, you would do something like keep adding one more star onto the end, and then return S. I prefer this one at the top simply because it's the easiest. Factorial. So this is supposed to return one times 2 times 3 times 4 all the way up to n. So somebody give me a way of doing that. Yeah. Nice. So you return a reduce of some array, And the reduce operation is x times y. And what's the array? Like that. Beautiful. So this says create an array that contains 1 through n, and on that array keep taking the take the first two elements and multiply them together, and then take that result and multiply it by the third element, and then take that result and multiply it by the fourth element, and so on. That's what this this lambda does here. This is just a function with no name that takes two arguments and multiplies them together. Any other way to do it? Yeah. So reduce takes an array and a function. So in this case, the array is 1, 2, 3, 4, 5, 6, and let's say 10. Let's say n is 10 in this case. So this is the array, and the function that I'm giving it as an argument is a function that takes two arguments and multiplies them together. So the way reduce works is it takes the first two elements of the array and applies that function to them. So it computes 1 times 2. That's 2. It takes this result that it's computed and uses that with the function with the next element of the array. So now it computes 2 times 3. That's 6. And now it takes this thing that's accumulated, 6, and multiplies that with the next element of the array. That's 6 times 4, which is 24. And then again, 24 times 5, which is 120. And so on. Then 120 times 6, that thing times 7, and so on. So it's a way of taking a function which takes only two arguments and using it to summarize a whole array. So just by scanning it left to right like this. So is that clear? What do you mean if you didn't have reduce? I mean, how would you write it without reduce?
No, what's lambda do without reduce?
Well, lambda is just another notation for defining functions, right? So we've seen you can define a function, let's call it mul, takes two arguments, x and y, and returns x times y. So that's one way to define a function. And if I say mul of 5 and 6, it's 30. It's 5 times 6. A shorthanded way, but I mean, this is great because it defines a function and gives it a name. But sometimes you don't actually even need a name for your function because you're just going to pass it in as an argument to something. So another way to define this function is to say, mul2 is lambda xy x times y. So mul2 is just a function. So this lambda notation says that this function takes these two arguments. They're called x and y, and its return value is x times y. It evaluates x times y. So it's just another way of writing a function. You don't normally write a function like this because it's not as easy to read, or it's not as maybe natural for us. But it is handy when you're trying to do something like reduce, which needs a function as an argument. It's a lot easier to just define it right here where you need it, rather than explicitly define a function that all it does is multiply two numbers together and have a name for that. Yeah? Yeah, there's a factorial function in the math library, but that doesn't, that's besides the point, let's say. Okay. How else would you write factorial? Is that the only way to do factorial? This is like the you can do it recursively, sure. And what does the recursive version of factorial look like? Is that right? And you need a base case. And here depends what you want to say factorial of 0 is, but you might say return 1 in that case. Any other ways? If you'd never programmed in Python before, never seen recursion, how would you do it? With a loop. So the standard, approach is there's some accumulator. We'll call it f. It starts out being equal to 1, and then you say for I in the range 1 to n plus 1, which means I is going to take on the values 1, 2, 3, 4, 5 up to n. You say f equals f times I. Return f. That's the sort of traditional way you would see it in most programming languages. Okay. So here's a function to write. It takes 3 arguments, a first name, a last name, and some title like Mr. or Doctor or Mrs. or whatever, professor, and writes it out, let's say, by saying writing the title, returns a string which contains the title first, and then the first name, and then the last name. How do you do that? So you want to return a string containing appellation, then first name, then last name, with spaces appropriately. Yeah.
Use the % sign placeholder.
So that's one way to do it. So if you want to use this printf formatting. So what are the things what kind of things are we printing? Strings. So what's the percent %s? And we're printing 3 of them, and we want to put spaces between them. And it's worth looking at exactly what's happening here. So we're actually writing we're applying a binary operator here. The left-hand argument is a string. There's this % operator, and then the right argument is actually a tuple, and the tuple should contain as many elements as there are things in here. So there's 3 things in here, so the tuple should contain 3 things, and those things are there. Okay. Any other ways to do this? So in new versions of Python, there's a string.format. Which looks like this. So it's actually part of the string class. String class contains a format method that takes any number of arguments you want to give it. And the string has to have some funny placeholders for where these things will appear in the string. The placeholders are curly braces, and there's all kinds of crap you can put in these curly braces to change the way things appear. In this case, you want the obvious thing to happen, so you'd like just the appellation to appear, the first name to appear, and the last name to appear. So I didn't bother teaching you this because Python's the only language that does it this way. And so it's not going to help you out with things like C or even C++. And you can look it up your own way. This percentage formatting has a much longer history and appears in a lot more languages. Any other way? Yeah, just add the strings together. So just add together the appellation, the string that has one space, the first name, the string that has one space, and the last name. That works too. Yeah? So you mean, what if I wrote it like this? Is that what you're asking? So anybody know what this does? What does a comma do? Creates tuples. So commas create tuples. So this doesn't actually return a string. This just returns a tuple that contains 3 strings. Now the print method will print this with spaces in between these things, but it's actually, what you've done is create a tuple here. So this doesn't answer the question. On the other hand, you know, if you want, here's another way to do it. It does answer the question. Join those 3 strings with the space as the separator. Lots and lots of ways to do things. So let's say A is an array of numbers, and X is a number. I want you to return an array that contains only the elements in A that are greater than X. How would you do that? What's the right tool for the job? So list comprehension. So somebody read off to me the list comprehension for doing that. Yeah. Yeah. Okay. So I want the value I for every I in A, but only if I is bigger than X. That's the way you read that. That's the best tool for it. If you don't remember list comprehensions, you will forever be stuck writing code like this. So if you don't know and learn how to use list comprehensions, you'll forever be stuck writing this kind of code over and over again, which is a fairly classic template. We've already shown how to write factorial this way. We've already shown how to append a bunch of strings together this way, but you know, it's a bit long-winded when you can write something as simple as this list comprehension. So,
Languages use list comprehension as well?
does what?
Other languages use it?
More and more. So they either use something like list comprehension, or there's something like what's called the select method, which takes two arguments. One is, and in fact, Python has a select method, but it's not needed once you have list comprehensions. So select takes two arguments. One is a function, and the other is a list. And it applies the function to each element of the list. If the function returns true, it keeps it. If it returns false, it throws it away. So, in fact, in Python, select lambda y, y is bigger than x, a. It's actually not called select, it's called filter. There you go. So that's another way of doing it in Python, and that's the way you'll see it typically in other languages. So this function here tells you whether or not to keep a value, and this is the list that you go through and filter. All right. So here's something non-trivial. Let's define a little class. Okay, so here I've defined a little class called place. It's really simple, it just has a name. And you can ask if one place is equal to another place, and two places are equal if their names are equal. So let's say place here. Okay, so is here equal to there? No. False. Okay, that's good. So, and why is that false? Because what happens when we check if here is equal to there? What does Python check? Well, it calls this underscore underscore equal method. The left-hand side of it is here, the right-hand side of so self is here, the other side is there, and those two names are not the same. On the other hand, if we say x equals a place called Canada, y equals a place called Canada, we can look at x and y. See, they're actually two different things. If you look at the addresses of these things, they're different. One finishes with B90, the other one finishes with 390. But x is equal to y, because they both have the same name. Is x y? No, because they're at different locations. So remember, is checking to see if this is really the same object. In this case, it's not. There are two different memory locations. But to check if they're equal, well, it just calls the equals method, which determines that they are equal because they have the same name. So here's something to look out for. Now, this is really tough to demonstrate, maybe. But let's make a big list of places. Equals. Well, actually, maybe we don't even need to do that. So here's a short list of places, x, y. See what happens here. So what happens if I turn places into a set? How big is the resulting set? Yeah? So if they're equal, set should never have two things in there that are equal. That's what a set means. So let's see it. All right. So 2. So what happened there, and why did this happen? Interesting. Somehow the set did something wrong here. Those 2 places shouldn't be in there. The set actually made a mistake. Let's try something a little more sophisticated. Let's say place Canada 4_ range. I don't know, let's say 50 of these things. So places is a list containing 50 occurrences of Canada. And if you look at these, you'll see they're all at different memory locations. Okay. So there's 50 of these places. Now I'll turn these into a set. What should happen? There should only be one because they're all equal. Let's see what does happen. There's 50. Unusual. Let's try it with a still bigger example. 5,000. 5,000 again. So somehow this set is broken. Any idea why? Yeah. Yeah. So the way sets work, and this requires knowing a little bit about data structures, and actually this is what I'm teaching my second-year students about what I taught them about 2 weeks ago, is the way sets work is they do something called hashing. And so remember, we still have these 2 places, x and y, that are both equal to Canada. And when you put something into a set, it gets hashed. That means it takes this thing, x, and somehow converts it to a number and uses that number as its location in an array. So we can look at, for example, hash of x and hash of y. And we see that hash of x and hash of y are actually different. And if you were to look at this more carefully and do the hexadecimal to decimal conversion, you'd realize that the hash of x and hash of y are just actually integer representations of their addresses. And so a set then says, well, these things have different hash values, so we'll put them in different places in the set. But that's a mistake. It shouldn't do that. In fact, the mistake is these things shouldn't have different hash values anymore. Things that are equal should have the same hash value. So here's a lesson for you that's going to probably hurt you more than once. If you define equal for an object, you should also define hash. Special built-in method called hash. And you need to define this thing so that two things which are equal have the same hash value. So in the case of places, two things are equal if they have the same name. So what should I be using to compute this hash?
Name turned into a number somehow.
So I should turn the name into a number somehow. Now the nice thing is Python can hash anything. And so what I can just hash, self.name. So let's try this again now and see if we get the right behavior. So I'll say x equals place Canada. So x and y are still two different places. They're at different locations. But x does equal y. And the hash of x is equal to the hash of y. Now, if I take x and y, and put them into a set, I get only one item. And the same thing is true if I put 100 of these or 1,000 of these into a set. There'll only be one. Okay? Now, if I create a new thing, I don't know, Z is Canada. Now, what if I add that to the set? Does it get added or not?
Yeah.
Yes, because it's not equal. So indeed, there's two things in there, and I can even print out the set, So I see both of these things there. Both of those things appear in the set. So a golden rule is if you create an object, a class, and you redefine equals, you need to redefine hash. And how do you redefine hash? Well, the important thing about hash is that it must return the same value for equal objects. And that's usually pretty easy to do because you just go up to the equal method. You see how comparison happens. So in this case, you compare the two names. And so you just hash the name. That way, if the names are equal, you get the same thing. If you had compared the names without caring about case, so if you converted them to lowercase first, then you should do the same thing when you compute the hash. And if you have something with multiple parts, so an example would be, let's say, so we've seen this example before of a person class two persons are considered equal if they have the same first name and the same last name. So since we've redefined what it means to be equal, we need to redefine hash. So what should the hash take? What should we hash? What should it be based on? First name and the last name. And Python nicely hashes just about anything except lists. But in particular, it hashes tuples. So the typical strategy is you just say hash the tuple self.firstname, self.lastname. If two different persons have the same first name and the same last name, then they will be hashing the same tuple, they'll get the same hash value. If you fail to do this, then sets will not work reliably. Yeah? You have to return, yes. Okay. So if you don't do something like this, then sets actually won't work reliably. You can add equal people to the same set, and they'll may both go in the set, or maybe they won't both go in the set. You'll never be sure what's going to happen. Yeah. Can I just what? The person thing? Yeah. Sure. Are they equal? Yes, same first name, same last name. Do they have the same hash value? They better. Yes. Can I add them both to the same set? No, you can't. So I don't know, let's say, now, which one is in the set? Can we figure it out? Well, we can actually. Me, him, and let's look who's in the set. The one in the set is the one that finishes with 9850, so that's actually me. So that's the first one we tried to add to the set. The second one got rejected. Yeah. Variable names won't help you because variable names could refer to equal things or different things or whatever. Yeah. Yep.
For sets will always be like the first one that'll stay in the last one, or the occurrence will get like that.
Yeah, so when you convert a list to a set, it just does the obvious thing. It goes through the list in order, adding things to the set. So the first one in the list will make it in. After that, subsequent ones won't be added. Okay. All right. Other than that, I mean, there's a sample exam for you to do. Just do it, and do please post to the forum when you come up with example questions for other people to do. Post them on the forum, and those who really want to practice for the midterm can use your example questions. Okay, so we'll leave it at there for today.
Is Pygame going to be covered in the midterm?
No.
Not at all. Okay. And also, do you know the answer to the bonus question?
What was the bonus question?
It was like, the percentage of getting it correct?
Oh,
Just
no, there's no correct answer.
Huh?
Yeah, there's no correct answer.
Yeah, that's
It's,
what I was thinking.
it's
There's two answers.
it's
like
a paradox.
1/4 or 2 bit.
Everybody got 1 mark for that question, though, yeah.
Oh, that's
Does it goes not to everyone?
Yes.
Can I ask you a question about assignment 7?
Yep.
In your video, when you move the ball around, your ball can go swing outside the screen. Do you want it to be able to do that?
Sure.
Because my ball moves a little differently. It doesn't swing quite as much. It's a little faster to react, so it doesn't.
Okay. I don't remember if it was super explicit about the...
It was very unexplicit, so I'm actually wondering about a few things like it.
Okay. So if it's not, I mean, if the equations for the movement of the ball are not explicitly defined, then you'll get different things depending on which constants you use. But basically, it's just looking at the vector from the ball to the mouse and somehow adding that to the vector of the ball, and then scaling down the previous value of the vector. So yeah, depending on what scales you use and stuff, it may be more responsive or less responsive. Yeah.
what time is the exam taking place?
It's in class.
In class?
4 o'clock. Yeah.
I'm wondering, there's no assignments for this week or next week, right?
Well, there's an assignment that's due in 2 weeks from yesterday. So basically, after the break, there's an assignment due on the Monday after the break.
So it's coming back after the break, or?
Yeah, so the Monday after the break, there's an assignment due.
On the midterms, there could be anything that's not on the pre-midterm exam.
There shouldn't be, I mean, there'll be different questions, but the subject matter will be the same.
Okay. Thank you. And as you just said, it'll be in class Thursday?
In class.
Okay.
Come to class.
Just to clarify, I already heard from someone, but Pi game is not on the...
Pi game is not on the midterm.
Okay, thank you.
Do the midterm covers all like the last lecture?
No, there's be no Pi game on the midterm.
Oh no, before by.
Yeah.
Thanks.
To assignment 5 or assignment 6?
Basically to, what was assignment 6?
That was the last one we just had.
Oh, okay. So everything up to assignment 5 then. And, and there may be some object stuff that may not have been explicitly in an assignment. Like the stuff I just talked about, sets, for example.
Well, anyways, the actual question I had was, about a week ago, I had to miss one of my tutorials because I was sick.
Okay.
And the only problem is exactly...
Okay, so the typical thing then, if you're not going to be getting full marks for tutorials because of that, and there's still a possibility that you'll get full marks because there's more tutorials than tutorial marks. You send me an email. You send me an email 1 week before, roughly 1 week before the final exam, and tell me you missed a tutorial because you were sick, and you lost a mark because of it, and then I'll add that mark back in when I do the final compilation of grades for the course.
So like a week before finals, I'll just remind you?
The week before the final exam, yeah, because there'll be a whole bunch of those, and I don't want them scattered, emails scattered throughout the term. I just want to gather them and do them all that week. But it's on you then. It's up to you.
Are PMC students writing the exam with the rest of the class on Thursday?
PMC students should be writing at the McIntyre Center.
Okay.
I booked for them, and I didn't receive anything that said they weren't doing that. For another course that I booked, I did receive notice that there wasn't enough room, but they didn't tell me there wasn't enough room for this. So.
Okay. I'll go check with them and see.
I hope.
I didn't receive a booking email, so I wasn't sure.
Okay. So I hope it works out. Otherwise, we may have some work to do. Yeah.